Now, let's consider the problem of the uniform circular motion at a constant speed. This problem is important to consider the Bohr model, which is a model for a hydrogen atom. Let's consider an object rotating at a constant speed around the circle with the radius r. We define angular velocity as omega. The omega represents the angle of motion per second, so after delta t seconds, the object travels by the omega delta t along the circular path. We also define the velocity at a given time as v, and the velocity after the delta t seconds as v prime. The question 1 is to determine the magnitude of velocity v. Although the v prime vector and the v vector are oriented differently, they are always the same size because of the uniform circular motion. The magnitude of the velocity is expressed by how many meters an object moves per second. After 1 second, the object moves by an angle of omega, and the length of this arc corresponds to the speed. This length is the radius times the angle, expressed as r omega. Therefore, the speed v is r omega. The question 2 is to determine the magnitude of the difference vector delta v, between the v prime vector and the v vector. The v vector is the velocity vector at a given time, and the v prime vector is the velocity vector after delta t seconds. The point to determine the difference vector is to translate the v prime vector so that the start points of v and v prime are aligned. Since this corresponds to the delta v vector, the length is determined by drawing. To do this, we need to consider the angle at which v and v prime meet. This angle is 90 degrees because it is tangent here. Also, because we translated it, it is now 90 degrees. If this angle is represented as a star mark, since it is a right triangle, the star mark plus omega delta t is 90 degrees. This angle is also 90 degrees because of the tangency. Because the star mark plus omega delta t is 90 degrees, the angle formed by v and v prime is also omega delta t. We will look at this part and determine the length of the delta v vector. As mentioned in question 1, the lengths of v and v prime are equal and can both be expressed as v, so the magnitude of the delta v vector corresponds to the length of the base of an isosceles triangle, with two sides v and the included angle omega delta t. Thus, the length of the base is expressed as 2v times sine omega delta t over 2. When delta t is close to 0, that is, when we consider momentary motion, the term inside the sine function approaches 0. In this case, using the approximate formula that sine x goes to x, the result becomes 2v omega delta t over 2, which is finally expressed as v omega delta t. Another idea is that in this figure, in the limit where v and v prime are so close together, the arc length and the straight line length are the same. Since the arc length is represented as v times omega delta t, we obtain the same answer for delta v as v omega delta t, approximating the straight length to the arc length. The question 3 is to consider the direction of the delta v vector in the limit where delta t is 0. Consider a picture with the v prime vector translated to the same starting point as the v vector, as in question 2. Since the v prime vector is the same size as the v vector, consider a diagram in which the v prime vector gradually approaches to the v vector in a circle with radius v. The difference vector delta v between the v and v prime can then be represented graphically. When delta t becomes close to 0, the delta v vector approaches to the tangent to v. The delta v vector also points toward the center of the circular motion, which is the same as force F vector. Finally, we consider an equation of motion. We can represent the acceleration, dividing the delta v vector by delta t, and take a limit where delta t is 0. The direction of the acceleration corresponds to the direction of the delta v vector, which is same to the direction of the force according to the previous discussion. The magnitude of the delta V is given as V omega delta t in question 2. When this is divided by delta t, the acceleration is obtained. Since delta t is just erased, it finally becomes V omega. Hence, we can write the equation of motion, ma equals F, where a is V omega. And from the answer to question 1, we can also express it as mr omega square equals F, by substituting r omega for V. You may learn this as a formula in high school, but I hope you understand that it can be derived only from the concept of the equation of motion.